So today we're doing something called function operations. So it's just going to be adding polynomials, subtracting polynomials, multiplying and dividing polynomials. So pretty easy stuff as long as you know what it's talking about, and then just considering a couple different things. So it says, your notes are the same as mine, so it says you can perform arithmetic operations on functions just as you do numbers or algebraic expressions. So basically you can add two functions just like you can add 2 plus 2 is what it's saying. You can add, subtract, multiply, or divide two different functions. That is true, just like we can add, subtract, multiply, divide 4 and 2. So everybody, this is some new notation. You've got to know the notation. But once again, once you realize what it's saying, it's pretty easy. So addition, look on your paper here. This is addition. So it says we have a function. So we have two different functions. We have f of x and we have g of x. They're just two different functions. Now these can be any function. So an example, right, of a function would be, for example, x plus 2. F of x could be x plus 2. And g of x, for example, could be x squared. Those are just examples of some functions. Random functions I made up. So you understand they could be anything, correct? Okay, so you're going to take two different functions, and this says f plus g of x. So we're literally just going to rewrite that. F plus g of x is literally just the same thing as f of x plus g of x. So then you would say, okay, it's addition, so you just add up those functions. Does that make sense? Just different notation. So this says f minus g of x. Anytime I see it written like this, I rewrite it like this. So that's the same thing as f of x minus g of x. So you'll literally just take f of x and subtract g of x, just like if I already had it written out in subtraction for you. Now I want you on your little notes to put a red flag. Put a flag on subtraction. It's one of the most missed problems. Because when people write in their own subtraction problems, they forget to put parentheses. So we're going to be subtracting all of g of x. So we've got to put parentheses around g of x to make sure we distribute our negative through. Because remember, when subtracting polynomials, you got to distribute the negative. So multiplication is, so this is f times g of x. So that's just f of x times by g of x. We'll always use parentheses on that, and then we'll distribute. You'll just multiply the functions. You get what I'm saying? No one's confused. And then this is f divided by g of x. So f of x divided by g of x. Now there's one little restriction here. Notice how it says g of x cannot equal 0. So basically, guys, if we have 2 divided by 0, I want you all, just for fun, type it into your calculator. So really quick, type in 2 divided by 0 for me. I'm interested to see what your phone does. So maybe try it on your phone too. So you guys with the graphing calculators, what does it say? It says error, okay? What does yours say on your phone? Error. So here's what the thing is, guys. We can never divide by a 0. You just cannot divide by 0. You can always have a 0 on top. That is totally fine. 0 divided by 2 is 0. Does everybody understand? But 2 divided by 0, you cannot divide by 0. 0 cannot be in the bottom of your fraction. So that's why they say the bottom, g of x, cannot equal 0. So we'll have to do that and then figure out what values would make the bottom 0. You'll see what I mean in a second. So is everybody kind of good with notation? You're just going to add the functions, subtract them, multiply them, or divide them. Okay, let's just start practicing. So down to your little problems here. So we have f of x is 15x plus 3. So that's f of x. Now g of x is 3x. So we're going to perform these operations here. So this says f plus g of x. I'm going to do it down here so I have more room to write. So I'm doing number 7. So you'll rewrite that as f of x plus g of x. So we're going to be adding up the two functions. So now let's go ahead and put in what is f of x. F of x is 15x plus 3. So instead of f of x, I'm writing what f of x is equal to. 15x plus 3. Is everybody good with that? Let's put it in parentheses just so that we get in the habit of doing that. Then adding g of x. So g of x is 3x, so we're replacing g of x to what it's equal to, add 3x. Does everybody see how I did that? So now you actually simplify it. So you say, what operation am I doing? It's addition. So addition, we're just combining like terms, right? So 15x plus 3x is how many x's? 18x's. So 18x's, we just combined like terms, and then we have plus 3. So we just added up f of x plus g of x, so that's our answer. Okay, let's do number 8. So this is f of x minus g of x. f of x minus g of x. So once again, rewriting f of x using parentheses, 15x plus 3, then you're subtracting g of x, which is 3x. We're subtracting the functions. So now subtraction is a red flag problem. We've just got to make sure to distribute if there's two terms. But this, do you see how this is only one term? Terms are separated by plus or minus signs, so this is only one term. So now let's combine like terms. 15x minus 3x is 12x's, correct? So we have positive 12x's, and then we have plus 3. So I just took care of those, and then we have plus 3. So there's our answer. That's f of x minus g of x. Pretty easy, right? So number 9, f of x times g of x. Hi. Did we get, so 3x times 15x is 45, and then x times x is x squared. Very good. Right? 45x squared. And then positive 3x times positive 3 is positive 9 and 1x, correct? Now there's no like terms. You can't combine an apple and an orange, so you're done. So that's our answer in standard form. Okay, let's do f of x divided by g of x. So f of x, this one's actually one of the easier ones for the most part because there's not really any simplification involved in secondary 2. So f of x on top will be 15x plus 3. Oh, this one does simplify. Over g of x. Okay, so over g of x, which is 3x. Okay. So before we do anything with this, what we're going to want to do is, so that is our answer, almost, we just got to simplify it if possible. But the first thing we've got to do is say, we know that g of x cannot equal 0, correct? The bottom cannot equal 0. That's one rule we need to know with division. So let's set g of x, let's set 3x equal to 0, and solve for x, because that's when x will be 0. Does that make sense? So set the bottom equal to 0 and solve for x. So how do we get x alone right now? What does multiplication? Division. So we're trying to get x alone. So divide by 3, divide by 3. 0 on top is totally fine. 0 divided by 3 is 0. So x equals 0 would make the bottom 0. Now why does that make sense? Isn't 3 times 0, 0? So do you see how we'd have to say that x cannot equal 0? Because that would make it undefined, correct? So with division, you'll have to say that one thing. You'll have to say when the bottom equals 0. So our answer is technically, here's the thing that most of the time it won't simplify, but so I'm like debating on whether or not to even talk about this at this level, but maybe we should since it's here. So technically this simplifies because here's why. Let's just focus on the top. What's there in common on top? 3. So let's factor out a 3. So we pull a 3 out, so divide by 3 to see what's left in our parentheses. 15x divided by 3 is 5x, correct? And then positive 3 divided by 3 is plus 1. Now on bottom we have a 3x. It didn't factor anymore. And we know part of our answer is x cannot equal 0. Okay. Now looking at this, do you see how we have a 3 on top and it's being multiplied? And a 3 on bottom and it's being multiplied? So aren't those the exact same thing? 3 over 3? So those technically divide out to be 1. So we usually in secondary 2, we don't really do any that have simplification because this is kind of a secondary 3 topic, but I think we're okay if that one's not too bad. Does that make sense, everybody? But usually if the top doesn't factor, then you won't divide anything out, basically. Does that make sense? Okay. So let's say this didn't simplify, and at this level I'd accept that as an answer, but I just wanted you to see it because I didn't want to be like, oh, this is all we can do because there's actually more we could do, or this would be an acceptable answer as well at this level. In secondary 3, this would be the only acceptable answer. All right, let's do a couple more. Okay, so number 11, I'm just down there, here we go. So we have two functions, g of x, f of x, we're doing g minus f. So this time we're doing g of x minus f of x. So g of x is that. So let's put it in parentheses. Negative x cubed plus x That's g of x. Then we're subtracting f of x. F of x is 2x plus 2. Subtraction is one of the most missed problems because people don't distribute the negative. So we don't need to distribute the negative here. There's not a negative in front of the entire function. So we just have negative x cubed plus x. We didn't have to change anything on that. But on this part, we've got to put in our negative 1 and distribute it through. So won't that be negative 1 times positive 2x is negative 2x? Does everybody understand? Now right here's where people miss it. Negative 1 times positive 2 is negative 2. So now we've distributed the negative through, so now all we have to do is combine like terms. A negative x cubed, there's no other x cubed, so we still have negative x cubed. 1x minus 2x, those are like terms. 1 apple minus 2 apples gives us negative 1 apples. The apple part doesn't change. 1x minus 2x is negative 1x. Does everybody understand right off that? I cross them out so I don't miss anything. And then we have our minus 2. So we can't combine anything else, so there's our answer. Okay, f of x, sorry, is everybody good? Okay, let's do the next example. Notice now it says find f plus g of t. So that just means we have a function of t, which is just like an x. We could use a smiley face for all, we don't care. You know what I mean? So a variable is a variable. So even though they're t's, there's no difference. So this is f of t plus g of t. So that just means the function f of t, which is t squared plus 1, and we're adding g of t, which is that function. So plus, I'm going to use parentheses, g of t is 2t plus 3. So I'm just adding up the functions. They just have t's instead of x's, but I shouldn't throw anybody off. Now let's combine like terms. Addition we don't have to be careful with. T squared, any other t squareds? No. So we have a t squared. Then we have our plus 2t's, no other t's. So plus 2t. The reason I did that first is because I like to put it in standard form as I go. Plus 1 plus 3 is plus 4. And now I've combined all like terms and it's in standard form. Pretty good, pretty easy. So only a couple more examples and then I'll let you work. Okay, so you've got to be able to do something a little bit different here. So it says, what is the sum? So sum means addition. We've got to know some of these keywords. What is the sum? So what is the sum? It says, what's f of x plus g of x? That means sum, so f of x plus g of x is what we're doing here, it says. So let's go ahead and do that. So f of x is 5x plus minus 7 plus g of x, which is negative 2x plus 1. Let's combine like terms. 5x minus 2x is positive 3x's. Negative 7 plus 1, negative 7 plus 1 is negative 6. Is everybody good with that? So we've answered the first part of the question, f of x plus g of x. Now it wants to know what's f plus g of negative 3. Instead of an x, we want a negative 3 here. Does everybody see that? So instead of an x, we answered the first one. Now it says, I don't want just f plus g of x, I want f plus g of negative 3. So now that we've added up f plus g of x, we're going to do f plus g of negative 3. So that would be replacing x with a negative 3 and calculating it. We're just saying, what's my function at negative 3? So that's when we plug something in. So you got to simplify correctly. Multiplication comes first, guys. 3 times negative 3 is negative 9. Negative 9 minus 6. So that's negative 15. So that would be our second answer. That was f plus g of negative 3. So we did f plus g of x, and then we just plugged in negative 3. Everybody good with that? Calculating, just like we were evaluating the other day, right? Like if I said, what's f of 2? You just plug a 2 in. That's no different. We just had to hurry and add up f of x plus g of x. Does that make sense? Okay. All right, so here we go. It says, explain how to find f divided by g of 5 if f of x is this and g of x is this. Okay, sweet. So let's first do, so this time we're doing f of g and then we're plugging in 5. So let's first do f of x divided by g of x. F of x divided by g of x. Here we go. So f of x is 2 minus 16x And g of x is 4x. Now let's restrict our domain just for practice. So we know that that's our answer as long as the bottom does not equal 0, correct? So you go off to the side and do some algebra. 4x equals 0. When is 4x going to equal 0? If x equals what? Divide by 4, divide by 4. X cannot equal 0. Isn't 4 times 0, 0? So that would be in our answer. This is our answer as long as x does not equal 0. That is our answer. But this one happens to simplify again. They must be in secondary 2, wanting you guys to start seeing it in ahead of time. So this answer would be considered acceptable, I would say, at this level. But let's say we wanted to simplify it. Well, let's keep going with this, and then we'll go back and simplify it if you're interested. So now we don't want just f of g of x, we want f of g of 5. So won't we just plug in 5 here, wherever there's an x? So that would be 2 minus 16 times 5 over 4 times 5. So let's calculate that. We've got to calculate the top first. So let's type it into our calculators. What's 2 minus 16 times 5? I need you guys to do it for me through. We have negative 78 over 4 times 5 is 20. So take your calculator. Take and do that. Negative 78 divided by 20. You get a decimal. Now change it back to a fraction. Yep, so we want the simplified answer. So negative 39 over 10 would be f divided by g of 5. That just means function f divided by g when we plug in 5. Everybody good with that? So there's our second answer. Okay, so once again, this would have been our first answer, f divided by g of x, but if you are an advanced learner, then you should be able to say, okay, I'm going to try to simplify this. Now, we can never just divide out in sections because of the subtraction sign, so we would factor out the top, because you can only divide out multiplication, if that makes sense. So what's in common on top here? What can we factor out? So let's pull out a 2. Divide by 2, divide by 2. So then left would be 1, 2 over 2 is 1, minus 8x. Does everybody understand? And then that's all over 4x, which is really just 4 times x. So the rule is with these, you can only divide out multiplication stuff. So if it's being multiplied, you can divide it out. So this is 2 times that stuff, correct? So we can divide out 2. That's 4 times x, so it can be divided out. 2 over 4 simplifies to be 1 over 2. So our simplified answer, if you were asked to simplify, 1 is left right here, so we don't need to write 1. We do have this 1 minus 8x on top. And on bottom, we had a 2 and an x left. So that would be the advanced answer as long as x does not equal 0. This would be like, oh, you really know what you're doing. Does that make sense? This would be like what you're expecting in secondary 2. Okay. Sweet. Okay, so now in a word problem, you can't let these throw you off because literally you just think about it in the real life and you just do what it's asking. A lot of times you're literally just adding them. It's just seeing if you know how to put 2 and 2 together. If I say to you, you owe me $1 and you owe me $1, how many dollars do you owe me together? That's $2. That's a word problem. Does that make sense to everybody? So it's a lot of times really easy. So let's read this and see if we can figure out what we're doing. So it says, the cost of manufacturing X amount of t-shirts is modeled by the function t is equal to 5x plus 12. So this is the cost of manufacturing t-shirts. Does everybody understand? That's the cost of manufacturing t-shirts. And then the cost of manufacturing sweatshirts, so this is the cost of manufacturing sweatshirts, is 15x plus 18. It says, what is a function giving the total cost of manufacturing t-shirts and sweatshirts? So in the real world, wouldn't you just be adding up the cost? Right? So it's really pretty easy. So the cost of the t-shirts plus the cost of the sweatshirts will equal total cost. So let's go ahead and write that in. So the cost of the t-shirts was 5x plus 12. That was the cost of the t-shirts, plus the cost of the sweatshirts was 15x plus 18, and that equals our total cost. That was a weirdo. Okay, so now combine like terms. Parentheses here. So 15x plus 5x is 20x's. 12 plus 18 is 30. 20x plus 30 equals total cost. I'm going to write TC for total cost. Does everybody understand? Makes sense. It costs you $5 to make t-shirts and $6 to make sweatshirts. The total cost will be adding them up to $11. Okay, so it says find the total cost of manufacturing 15 t-shirts and 15 sweatshirts. Okay, so we could go back to here. So wasn't this t-shirts and this was sweatshirts, correct? So this is total cost. So that would be a total of how many items? 15 and 15 plus 15 is 30, correct? We could plug in 30 into the total cost, or we could plug them in individually up here. This could be 15 and this could be 15. This is cost of t-shirts, correct? So if we plug in 15 here, that would be the cost of 15 t-shirts. Does that make sense? And if we plug in 15 here, that'd be the cost of 15 sweatshirts. So you can either go back and plug in 15 up here in X and 15 right here for X, or we can plug in 30 down here. So this is the total, if we were adding up the total. Does that help a little bit? Which one makes more sense to you? Yeah. Down there? Okay, plug in 30. So 20 times 30 is what? And then plus 30 is? 630. So our total cost will be total cost is $630. I'm just curious. I want to make sure I'm not lying to you. It makes sense to me. Yeah, it makes total sense. So let me just have you type this into your calculator to make sure if we did it the other way, it comes out the same. If not, I got to figure out why I'm wrong. So so just type this in. 5 times 15 into your calculator plus 12. What do we get for cost of just t-shirt? $87. Okay, perfect. Plus, let's plug in the cost of a sweatshirt. So 15 times 15 plus 18. So are you sure when you calculated? Okay, so I did lie to you. Why is that not right? So that's not, add those up. 243 plus 87. 370? 330. They're not the same. So I'm feeling like, sorry, I thought about that wrong. Total cost of. Okay, this one was wrong. Sorry about that. I just wasn't thinking right. This one's wrong because, well, why is that wrong? Oh, because, well, yes, that's what it is. So it makes more sense to me to do it back up here. Because otherwise you're like, why? Yeah, it was only 15 we should have put in for X, because X was the same. Right here we combined them, does that make sense? And so then the total cost will be, yeah. So just, if it makes more sense for me to do it up here. Does that make sense? And individually add them up and then add them up, because in the real world, that's what you would do. You would go figure out how much it costs for you to make a t-shirt, how much it costs for you to make sweatshirts, and then you'd add up the cost. So yeah, sorry about that. I usually don't lie to you very often mathematically. I just didn't think very hard about that. Okay, hopefully I didn't confuse anybody too much. Okay, just a couple more. These are the last two that I'm going to let you just go for it. So here we go, 17 and 18. So notice there's a couple different things here. Notice what we're asked to find is g plus 5h of x. So let's write this out. This is really, so it's addition, correct? So we're going to be doing g of x plus, then it says 5 times h. So that'll be 5 times h of x. You would write it out like this. Does everybody see how I wrote it out like that? Because that was the function g plus 5 times the function h. Okay, so g of x is x squared minus 1. We're adding that to 5 times h of x. So 5 times h of x is this, 2x minus 1. And that is our answer, but now we just simplify it. So remember, multiplication comes before addition. So let's multiply the 5. Well, first of all, we're not going to be doing anything with this x squared minus 1 right now, so I'm going to rewrite it. Then we're distributing positive. We've got to multiply before we combine like terms or do anything else. Positive 5 times 2x is positive 10x, correct? And then positive 5 times negative 1 is negative 5. So now we're just combining like terms. We're just adding them up now. X squared, no other x squareds, plus 10x, no other x's. Minus 1, minus 5, guys, is minus 6. And there's our answer. Last one. So it says 4 times f of x plus 4 times g of x. So let's write, so that one's already written out nice and pretty. So let's write it out. 4 times f of x is 3x minus 1. Then we're adding 4 times g of x, and g of x is x squared plus 5. So you're just putting in what you know. Multiplication comes before addition. So we got to multiply this in first. 4 times 3x is positive 12x. Positive 4 times negative 1. Negative 4. Then we have our positive 4 times x squared, which is positive 4x squared. And then positive 4 times positive 5 is plus 20. So did you see how I did that? Any confusion? So now we'll combine like terms, starting with the highest degree. Positive 4x squared. There's no other x squareds. Positive 12x, there's no other x's, so plus 12x. Now negative 4 plus 20 is positive 16. So we just did that and simplified. Okay, are you guys going to be able to do this? You all good? Okay, check them off with me after you've done them. For a couple, if you're not sure if you're getting them right, if you have questions.